That was a sonic boom, a sound closely associated with the speed of sound and breaking the sound barrier. But what exactly is the speed of sound, and why does it go boom when you go faster than it? Welcome to On the Shoulders of Science. I'm Ben, and if this is your first time here and you want to learn about cool and interesting scientific facts and concepts in a fun and easy to understand way, start now by subscribing and clicking the bell so you don't miss anything. Well, the speed of sound is, you guessed it, the speed at which sound propagates through a fluid or material. But it's not only that. The speed of sound also represents the speed at which a physical wave moves through an object. For example, if I whack the end of this steel rod, what I'm really doing is sending a sort of shock wave down the rod. And that doesn't happen instantaneously. It takes time for these atoms to bump and transfer their energy into the next atoms, and to the next atoms, and the next atoms, and so on. And in steel, it happens to be about 11,450 miles per hour, meaning it takes about 0.18 milliseconds for the effect of my whack to reach the opposite end. And note that sound is the same thing, except a constant stream of waves coming in at a given frequency. Now in air, the speed of sound is much slower. Because the atoms in the air are further apart, it takes more time for a sound wave to propagate. So the speed of sound in air at sea level and 20 degrees Celsius is about 767 miles per hour. Okay, but what about when you're in a jet going faster than the speed of sound? Well, I think this animation describes it best. If the jet is stationary, the sound of its engine propagates radially in every direction. But when it starts moving, well, you can see what happens. Sound still travels at the same speed, but now the jet is moving toward these sound waves, causing them to get stretched on this side and squashed over here. As you go faster and faster, the sound waves bunch up more and more until you pass the speed of sound and they all occupy nearly the same space, creating a conical shock wave that travels behind it, a sonic boom. So this means that a sonic boom isn't just a sound that booms once right when you start going faster than the speed of sound. No, it's a characteristic of a supersonic object. It constantly booms, and you only hear it when the conical shock wave passes over you. And because of their peculiar nature, there are a few more interesting things to note. 1. If you're moving positioned right in front of a jet going faster than the speed of sound, the sound waves coming from the jet aren't going fast enough to catch up to you, so you won't be able to hear the jet at all. And 2, if you manage to stay consistently inside but not on the sonic boom cone, you will never hear a sonic boom because the boom never reaches you. And 3, if you manage to fly the exact same speed as the plane and somehow stay right on the cone, right on the sonic boom, you would hear a constant sonic boom. Probably not the easiest on your eardrums. Now, if you want to learn more about some difficulties jets face when trying to break the sound barrier, as well as explaining images like this, make sure to subscribe to On the Shoulders of Science so you don't miss my next video on breaking the sound barrier. Thank you all for watching, I hope you learned something, and I'll see you next time.